Okay, this is concept number 1 for quarter 4, and it's simplifying rational expressions. So it's going to use a lot of the same topics and ideas that we finished up quarter 3 with in the factoring section. So you're simplifying, they're called rational expressions. And that really just means that it's a fraction in which the numerator and the denominator are polynomials. Okay? The denominator also is not equal to 0. So that's your rational expression. It just means that it's a fraction. Okay, so we're starting out dealing with fractions that are some sort of a polynomial. Okay, so maybe it's a monomial, maybe it's a binomial, it could be a trinomial, it could be any of those types of polynomials that we've dealt with in the past. Okay. Then we have as another definition, restricted values. Okay, these are just values that will make the denominator equal to 0, which remember, you're never allowed to have. Denominators are not allowed to equal 0. You can't divide by that. If you were to type in anything divided by 0 in your calculator, it's going to give you an error message, okay, because the denominators are never allowed to equal 0. So a restricted value is just some extra information that they'll tell you about the problem. So in our first example, we have 30a squared b divided by 81ab squared. We are trying to basically reduce this fraction. Okay? It's a monomial divided by another monomial. So we're really just reducing the fraction. So we start just looking at the whole numbers. I have a 30 divided by 81. That does not divide evenly, so all we can do is reduce. Right? This just goes back to elementary school of reducing fractions. 30 and 81. They're both, in this case, divisible by 3. Right? 30 divided by 3 is 10. 81 divided by 3 is 27. Okay? So it's just reducing that fraction, which, again, is an elementary topic. Okay? You have to be able to reduce fractions. And then we look at the variables. Well, we have an a squared divided by an a. You had 2. You're taking 1 away, so you have 1 left. So you have an a to the first left. In your b's, you have a b in the numerator and a b to the second in the denominator. Okay. B divided by b squared. There are more of them in the denominator. So that b on the top cancels out with one of them in the bottom. So there is a b to the first left in the denominator, which means there's still a 1 in the numerator. Okay, you have to be very careful when the larger of the two, when the exponent in the bottom in the denominator is bigger than that in the numerator. Okay, be very careful. Wherever there's more of them at, that's where your leftovers are going to stay. Okay. So with the a's, we had an a to the second and an a to the first. There were more of them in the numerator, so what I have left over is in the numerator. There were more b's in the denominator, so when I think about canceling them out, what's left over is in the denominator, wherever there were more of them at originally. Okay? Now, you have to combine all these pieces in your final answer. So your original fraction from the 30 over 81 became a 10 over 27. Then we had an a left in the numerator and a b left in the denominator. So 10a over 27b. Okay? It's just really reducing fractions when you have a monomial over another monomial. 2 more examples on this slide here. Again, we're simplifying the rational expression. So I have 32 m to the third times n divided by 48 m squared n to the fifth. Again, they're both monomials, so you're just reducing the fraction. 32 over 48. The biggest number you can divide evenly is going to be a 16 in this case. Okay, 32 divided by 16 is going to give you 2. 48 divided by 16 gives you 3. If you don't realize it's a 16 at first, that's fine. You can start with something smaller, but then you're going to have to reduce a second time. Okay, or maybe a third time if you don't get the largest then. Okay, sometimes it's going to take you more than one step. Other times you might get the largest right off the bat and be fine with doing it in one step. Then we look at our variables. We have an m to the third in the numerator and m to the second in the denominator. So you subtract your exponent. There's more of them in the numerator, so it's an m to the first. N over an n to the fifth. Again, you can subtract them. You have a 1 and a 5, so you're going to have 4 left over. There were more in the denominator originally, So that's where the answer gets put. So your final answer when you combine all that back together, 2/3 m in the numerator, n to the 4th, connected to 3 in the denominator. Now we have 10xy divided by 50xy squared. 10 over 50 reduces to give you a 1/5. They're both divisible by 10. 10 divided by 10 is 1. 50 divided by 10 is 5. Your x's completely cancel out. I only had 1 to begin with, and I'm taking that 1 away. Those completely cancel out. Your y's, on the other hand, you have 1 in the numerator, 2 in the denominator. So when you cancel there, you still have 1 left over in the denominator. So we have a 1 over a 5y for our final answer. Okay, you're just combining all of that back together. Now, the second part of this, we have something a little bit bigger than a monomial. Simplify the following rational expressions. Okay, so in this example, we have a polynomial, which is in this case a binomial in the numerator, divided by a monomial. Okay, so it's not as simple as the original two, but just requires a small amount more of work. Before we can just reduce the fraction, we first have to do some factoring of that numerator. Okay, so I have a binomial up top. Before I can reduce anything, I have to see if I can factor out a GCF out of here. So if I factor that numerator, my GCF between 75 and 50, the largest number that divides evenly into both of them, is 25. Then if you look at your variables, we have an h that's common to both, so that's going to be part of my GCF, and the smallest that I originally had was an h to the first power. So my GCF is just a 25h. Then remember, when we're factoring out the GCF, we have to divide that by each of the initial terms. So if I have a 75h squared, and I'm dividing it by 25h, I have 3h left over. Minus 50h divided by 25h is just going to be a minus 2. Then I can rewrite the denominator as a 5h squared. So all I did was factor out 25h out of that numerator. Once you have that factored out, because these are both monomials, so the 25h and the 5h squared are monomials, those can be reduced. So we're just going to reduce that portion of it. 25 divided by 5, I can do that division, that's going to give us a 5. H over an h squared. Okay. When I cancel those out, this h in the numerator completely cancels with one of them in the denominator, so I still have one left over in the denominator. So this reduces to 5 over h. Now, when I reduce that, this 3h minus 2 stays the same. It just gets carried to your answer. All I did was reduce those monomials, but that binomial that was left over stays in your final answer. So our final answer then is the 5 times 3h minus 2. All of that is being divided by h. Okay, so I just reduced these monomials as much as I could, and then I kept that 3h minus 2 attached to the numerator. Two more examples here, both with binomials in the numerator. So I have a 6x squared plus 9x divided by 18x squared. Again, factoring out a GCF out of that numerator since it's a binomial. Your GCF is going to be a 3x to the first power. So you divide each of those terms. 6x squared divided by 3x leaves us with a 2x. 9x divided by a 3x leaves us with 3. Then we can rewrite the denominator of our fraction and reduce 3 and 18. Okay? That reduces. 3 divided by 3 is a 1. 18 divided by 3 gives us a 6. I have an x to the first power and an x to the second power. That x in the numerator cancels out with one of them in the denominator, leaves me with 1 left over. So that's going to reduce to a 1 over 6x, technically. Okay. Still have a 2x plus 3 in our numerator. That entire 3x canceled out, so it's just a 1 connected to it, which you don't need. So we just write the 2x plus 3. then our denominator becomes a 6x. Okay? That 18, remember, reduced and became a 6, and we still had an x left over in our denominator. Same thing here, 12a to the third b minus 24a squared b squared. Find a GCF first and factor it out. So your GCF is a 12a squared b. When you factor that out of your original terms, you're left with an a minus 2b. Then you go through and you reduce that monomial with the monomial in your denominator. So it's exactly like the original ones. Okay, you just have to add in that step of factoring out the GCF first. Okay, 12 over 36 reduces to a 1 over a 3. A squared over a leaves you with an a in the numerator, and your b's completely cancel out. So that portion just reduces to a over 3. But remember, this a minus 2b has to get carried along to your answer. Okay, so you have an a times the quantity of a minus 2b. All of that is being divided by 3. The majority of this just goes back to reducing fractions. Okay? If they're both monomials, then you can just go straight to reducing the fraction. If you have a binomial in there, you're going to have to look for a GCF first so that you can make a monomial to reduce with your denominator. Again, this is your first concept of quarter 4, simplifying rational expressions with monomials.